Before we get started, it is worth noting that remember, I keep my doors open at night because it gets really hot, and there is a cricket that is absolutely going bonkers right now. I don't know if you all can hear it, but it's very distracting. I hope it's not something you can hear, but I don't have time to wait for this stupid thing to stop, and I don't know where it is. But with all that said, we're going to dive into topic two, which is going to be just a general strategy for simplifying. So we're going to do essentially two things in this worksheet. We're going to simplify some statements, some expressions that involve trig functions, and our goal is to simplify them into something that maybe we can use later. So something that's maybe easier for us to use or quite literally simplified. And then the other thing we're going to do is we're going to take statements that are said to be true and we're going to prove it. We're going to show that they're equal. Okay. So for this first part, we're just simplifying. We're seeing if we can take one expression and rewrite it as something that is more useful to us, okay? And unfortunately, there's not like an algorithm for how to do this because each expression is a little bit different, and what you need to do for one may not be what you need to do for another. And this can sometimes be frustrating for students because we want like a step one, a step two, a step three, a step four. And unfortunately, that ain't gonna work here, okay? So what we have given you are some tips and tricks to try. So before we even look at the possible steps you could take for simplifying expressions, do two things for me. Don't use pen and be willing to erase. Okay. These are the type of situation where sometimes you got to try something, and if it goes south, try something else. Okay. So you just have to be willing to try things. Okay. So don't use pen, be willing to erase and try new things. Okay. Now, with that said, there are some tips that we can use. Okay. So we've got a toolbox full of all sorts of stuff that we know how to use. And here are a few things that are really, really helpful. The first thing that can be super helpful is multiplying by a form of one. You'll hear some people say multiply by a well-chosen one. So what that means is multiply by something. It may not look like one, but if you multiply by something that has a value of one, you're not changing the value of what you're starting with. You're finding a way to manipulate it and morph it into something that's more useful. So always look to see, no, I don't want to say always, but one of the tips you can do is look to see if there's a one that you can multiply by that might help you simplify. Another thing you can do, especially when you're adding and subtracting expressions, is look to see if you have a common denominator. Okay, that can be a big one. Sometimes rewriting things over a common denominator can really make things fall into place nicely. Okay, another thing that you can definitely use is factoring. So we have three examples where we're going to do each of these three potential steps that can help you simplify. And just remember, your goal is to essentially take one expression and rewrite it as something that maybe is going to be useful to us in another way. Okay, so let's go ahead and get started here. This cricket is driving me nuts. Okay. All right. So for example, on the direction, just say simplify. And remember, that literally means just rewrite this expression as something that's equivalent, just maybe easier for us to use. Okay. And for part A, we have sine of theta over 1 plus cosine of theta. Well, this is great. Okay. Lovely. What do we do? Okay. And you just have to kind of be willing to try something. And the first thing on our list of, a general strategy for simplifying is to multiply by a form of one. Okay. Well, great. There are infinitely many forms of one. And so I want you to kind of travel down the road back to 171. In 171, there were two situations where you would have potentially multiplied numerator and denominator by a conjugate of the denominator. This would occur when you're dividing complex numbers. This would also occur when you're dealing with potentially rationalizing denominators where you have a sum or a difference in your denominator. Okay, so for instance, let's just use complex numbers. Let's say you had something like 2i over 3 plus 4i. Well, the way we learn how to divide complex numbers is we multiply the numerator and denominator by the conjugate of the denominator. So we would multiply by 3 minus 4i over 3 minus 4i. And the reason for this is when you multiply conjugates, so multiplication of conjugates, it simplifies nicely. So let's see how that works in this world of trigonometry. So I have a denominator of 1 plus cosine of theta. Let's go ahead and multiply numerator and denominator by 1 minus cosine of theta, and let's see what happens. So we're going to multiply top and bottom by 1 minus cosine of theta. Okay. And for the numerator, I'm just going to leave it kind of factored. I'm not going to do anything crazy with it. So for the numerator, I'm just going to leave it sine of theta times 1 minus cosine of theta. And then in the denominator, let's see what happens. So we can go ahead and just do that FOIL method and see how things work out, because you may have forgotten how these conjugates simplify when you multiply. So we're going to take 1 and multiply it by 1. That's easy. We just get 1. Then we're going to take 1 and multiply it by negative cosine theta. Well, that's just negative cosine theta. Then we're going to take the cosine theta and multiply it by 1. So we get plus cosine theta. And then we're going to take cosine theta and multiply it by negative cosine theta, and we get negative cosine squared of theta. So hopefully this is triggering something and you're like, I kind of remember this. Remember, when you multiply conjugates, those middle terms always cancel. So we actually learn a shortcut for multiplying conjugates where we just multiply the first terms and the last terms. We don't even do the full FOIL method. So at this point, this simplifies to sine of theta times 1 minus cosine of theta, and that's all over 1 minus cosine squared of theta. Well, what do we do with this? Okay. So let's see here. Let's see if we could rewrite the denominator in particular, because in my mind, I'm thinking cosine squared and 1. I can always remember cosine squared and 1 go very nicely with sine squared, okay? So let's mosey on up to the first page here where we had our Pythagorean identities. So let's think about this right here. So we have sine squared theta plus cosine squared theta equals 1. That's not exactly what we had. Remember, we had 1 minus cosine squared theta. But if I take this right here and I subtract cosine squared theta from both sides, I end up with sine squared theta equals 1 minus cosine squared theta. Well, that could be helpful because this is exactly what I have in my denominator. So we know that 1 minus cosine squared theta is actually equal to sine squared theta. So let's put that down here. Whoops. So this is now equal to sine of theta times 1 minus cosine theta all over sine squared theta. Okay. And then when we have sine squared theta over, or when we have sine of theta over sine squared theta, that kind of reduces. This sine of theta will say kind of divides into this one. And what we're left with is 1 minus cosine theta over sine of theta. So we need to be really mindful of how we write our final answer. We know this has finally simplified to 1 minus cosine theta over sine theta, but we want to be very clear that these two things are equal. So we want to say, okay, sine theta over 1 plus cosine theta is equal to 1 minus cosine theta over sine theta. So just make it really clear that you've shown that two things are equal to each other. And this may not seem shockingly simple. Okay, they look like they're fairly equivalent, but this is going to come up in a bit. Okay, so you'll see this again. All right, so that is how you can multiply by a well-chosen one or a weird form of one to take something and rewrite it into something else that might be more useful. Now, for part B, Part B, this is the kind of stuff where students cringe because it doesn't matter what level of student you are, students tend to get frustrated with fractions. I don't know why. I think they're lovely, but here we are. Okay, so I have 1 over 1 minus sine of theta plus 1 over 1 plus, let me say that again. I have 1 over 1 minus sine of theta plus 1 over 1 plus sine of theta. And step 2 in our general strategy for simplifying is to rewrite the expression over a common denominator. Let's see what happens when we rewrite this over a common denominator. Okay, so in order to do this, I need to multiply the first expression by the denominator of the second expression, top and bottom. And then I need to multiply the second expression by the denominator of the first expression, top and bottom. So let me just write this out so you can see it. Remember, don't try to scrunch this. Give yourself plenty of space, okay? So for the first expression, I have 1 over 1 minus sine of theta. I'm going to multiply top and bottom by 1 plus sine of theta over 1 plus sine of theta. And then I'm going to multiply the second expression by 1 minus sine of theta top and bottom. Okay, so we're actually doing two things. We're finding a common denominator, but in finding a common denominator, we have to multiply by those weird forms of 1. Okay, so let's see what this gives us. In the denominator, we now have 1 minus sine theta times 1 plus cosine of theta in each expression. So we now have a common denominator. So we can say, okay, our common denominator is 1 minus sine theta times 1 plus sine theta. And then in my numerator, I've got this expression here. So 1 times 1 plus sine of theta, and then plus 1 times 1 minus sine of theta. So multiplying by those ones right here and here, nothing's really going to happen. So my numerator is going to be 1 plus sine of theta plus 1 minus sine of theta. So we essentially distribute these ones, and then we just write our numerators over a common denominator. And let's see if we can simplify. Okay, so in the numerator, I have 1 plus 1. So let's make sure you see this. 1 plus 1. Okay, that just gives me 2. Okay, so 1 plus 1 is 2. And then sine of theta minus sine of theta, that's just 0. Okay, so my numerator is really just 2. Okay. And then my denominator, let's multiply, okay? So in the denominator, we can do the full FOIL method, or you may notice that in the denominator, we have something that looks like those conjugate pairs. And when you have something that looks like those conjugate pairs, things simplify really nicely. So you don't have to do the full FOIL method. You can just multiply the first two terms and then the second two terms. So 1 times 1 is 1. And then negative sine theta times positive sine theta is negative sine squared theta. So let's think about this. Okay, let's go back up to our list of identities. Okay, now I'm going to erase the work from the previous example here. Anytime I see cosine or sine squared with a 1, I automatically think of this identity right here. Can I manipulate this identity so that I get what I'm looking for? Well, I know that I have 1 minus sine of theta. So if I were to take both sides of this and subtract sine squared of theta, I think I said sine of theta, I meant sine squared of theta. If I were to take both sides and subtract sine squared theta, I would be left with cosine squared theta equals 1 minus sine squared theta. And that's exactly what I have in my denominator for part B. So let's see if we can rewrite that denominator as just cosine squared theta. And we can. So this is really just 2 over cosine squared theta. Okay, so again, just be really careful. Make sure you make it super, super obvious that these things are equal. So I would erase these little lines here just to give myself a little bit of space. I would say, okay, finally, 1 over 1 minus sine of theta plus 1 over 1 plus sine of theta is really 2 over cosine squared theta. So we have now established that these two things are equal. Okay, so that is example 1. So we've looked at 2 examples where we could simplify. In both cases, we ended up working with a weird form of 1. We also had to work with an LCD or finding a common denominator. So we've basically looked at our first 2 steps here for just some basic steps to simplify these expressions. We're now going to look at potentially factoring, not even potentially factoring. We're going to flat out look at factoring. Okay, so example 2, it says use factoring techniques to simplify. So I have 1 minus cosine squared v over sine v plus cosine of v times sine of v. So what could we possibly do here? Well, you need to, again, mosey on back to 171. In 171, we had this situation called difference of squares, okay? And when we had difference of squares, we could have something like x squared minus 9. So we have 2 things that are perfect squares, and they were being subtracted from each other. So what we could do is we could take the square root of each term, so x and 3 in this case, and then we would add them and subtract them. So it's kind of like working in reverse. Up here, we talked about that idea of those conjugates and how if you multiply things that look like conjugates, you get something really nice. Well, this is sort of working backwards. It's like a similar idea, but here we're dealing very specifically with 2 perfect squares, okay? So let's see what this numerator could potentially look like. So 1 is definitely a perfect square. Cosine squared is definitely a perfect square. So let's rewrite this as a difference of perfect squares, okay? So the difference of perfect squares is going to factor very nicely as 1 minus cosine theta, or not theta, please put a v there. and then 1 plus cosine of v. And then in my denominator, what could I possibly do here? I see two terms, and two terms clearly both have sine of v. So let's see if we can factor out a GCF, okay? So factoring out a GCF, we could have something like 4x plus 12. Well, 4x and 12 have a common factor of 4, so we would take the 4, and we basically divide the two terms by 4. So 4x divided by 4 is x, 12 divided by 4 is 3. We've written this as a product. We want to do the exact same thing here, but we're going to have a GCF that is sine of v. So I'm going to take the sine of v and move it out front, and then I'm going to divide both terms by sine of v. Well, sine of v right here divided by itself is just 1, and then cosine of v times sine of v divided by sine of v is just cosine of v. And now what do you notice? Hopefully you see here that we have a common factor. You can always, like, once you factor anything, like when you were dealing with like rational expressions, once you factor, always look to see if you have common factors that could simplify out. And in this case, we do. We have a 1 plus cosine of v over a 1 plus cosine of v. So those just divide out to be 1. Okay, so that leaves us with 1 minus cosine of v over sine of v. And that's it. Okay, so there you have it. We've looked at the three different tips or steps that you can potentially use for simplifying these expressions. We love to tell you that there's a do this first, do this second, do this third, do this fourth. We love to do that in math. We love to come up with these algorithms that always work, and that's a lot of what we do in math. But there are some situations where you have to think outside the box and be creative and just be willing to try something. So use pencil, give yourself plenty of space, and if something you try something and it's going nowhere, start over with something new. Okay? So just be willing to try new things here. Okay?